The best test ever is back after an emotional occasion. Explorer 1 is presently returning information from every one of the 4 instruments, and the mission proceeds. Explorer 1 has now entered profoundly into interstellar space and is giving us exceptional impressions from there. However, what had really happened? Why did the test send trash information for close to a portion of a year? And what stroke of virtuoso was utilized to fix Explorer 1? Explorer 1 was viewed as lost. The area of the test was still reasonably clear, yet the information had been unusable since the fall of 2023. The NASA Control Center in Pasadena only received secretive messages comprising of ones and zeros that looked bad. For a really long time, the team struggled to save the test. Then came the sad day when NASA announced that the Explorer 1 mission was likely finished for good. What a delight it was when the return of the test was reported only a few weeks later. Explorer 1 is back. Later, in the fall of 2023, Explorer 1 began sending vast amounts of data to Earth. Communication, which had worked easily since the mission was launched in 1977, was abruptly disrupted. Researchers and engineers at NASA were confused for months. The hogwash told NASA engineers that the scientific instruments aboard the space test were still working. However, the data received could no longer be deciphered. This caused incredible concern. At over 20 billion kilometers away from Earth, the test is a significant instrument. Until recently, never had a test sent information from interstellar space. NASA is doing its absolute best to get this veteran of space exploration up and running again. Specialists attempted to decipher the test's messages to make inferences about the blunder. However, even the most brilliant professionals and unraveling specialists initially came up with nothing. Then came the first breakthrough. A researcher from the Deep Space Organization, which monitors the test's communications, was able to read the directive for the first time. Explorer 1 was forever sending a complete record of its memory and instruction system. This was uplifting news because these systems are like the heart and brain of the test. So, Explorer 1 was alive. However, how it was sending information was messed up. Despite this acknowledgement, further investigating was troublesome. The primary issue lay in the sheer distance from Explorer 1 to Earth. Radio transmissions take over 22 hours to travel the distance in one direction. This meant that any diagnostic method took nearly 2 days to initially get a response. The engineers focused on the flight data subsystem, which is responsible for packaging and communicating the scientific data. Initial analysis showed that a particular chip inside the subsystem might not have been. Millions of fans of the test around the world were eagerly awaiting the information. NASA kept researchers and space enthusiasts up to date, posting efforts, sharing progress, and candidly admitting disappointments. In February 2024, NASA's mission director announced in a public statement that the mission was slowly coming to an end. There was perfect bitterness, but there was also hope. Despite the difficulties, some scientists didn't give up. Tips and suggestions on how to bring Explorer back to life kept coming in from all over the country and from experts globally. NASA decided to press on and pursue an intriguing new approach. The idea was quite simple. The faulty code was redirected to another part of the SDS. This was not without risk, as it might have meant permanent radio silence. The process required exact coordination and timing. Each signal sent to Explorer 1 had to be carefully tuned to avoid causing further damage. On April 20, 2024, the extraordinary finally occurred. After years of effort and countless hours of hard work and dedication, Explorer 1 was once again sending comprehensible information to Earth. Can you imagine the joy and celebration at NASA when the data was checked out again? It got even better. All 4 scientific instruments on board the space test that are still relevant were fully functional again. This win once again launched Explorer 1's mission into the realm of absolute space legends. The restoration of communication with Explorer 1 was not just a technical achievement but also an emotional triumph. What's more, the scientists and engineers involved worldwide celebrated. After the problems of 2021 and 2022, this was the second successful fix on a test that is over 20 billion kilometers away and has been traveling through space for over 45 years. The story of Explorer 1 will continue, and who knows what mysteries interstellar space still has in store for us. The stunning continuation of Explorer 1's mission is remarkable. This test could continue to send us information for another 10 years or so. The batteries will likely finally fail in the mid-2030s. Following the successful resumption of the mission in April 2024, Explorer 1 is now once again at the forefront of interstellar exploration. The space test has already provided invaluable information on the outer planets and the boundary regions of our solar system. Now, it's penetrating ever deeper into the vast realm of interstellar space and exploring unknown regions. The scientific goals and expectations lie in particle measurements from interstellar space, as well as investigations into cosmic radiation and magnetic fields. This data helps scientists better understand the structure and composition of space beyond the heliosphere, our sun's protective bubble. Behind this bubble, a completely different kind of space begins. Plasma waves are particularly interesting. These waves provide us with information about the density and movement of the interstellar medium, and this will help us understand the entire universe a bit better. As Explorer 1 is the only test exploring this region, the information acquired will be crucial for astronomy. This medium constitutes the largest part of the galaxy beyond the bounds of our Milky Way. Beyond the galaxy lies the even more immense intergalactic space. We don't know what is truly happening in interstellar space. All of our knowledge to date has been based on estimates, measurements, and assumptions. Science has confirmed some of these assumptions, but others have turned out to be complete mistakes. Explorer 1 demonstrated this once before when it crossed from the heliosphere into interstellar space. Scientists had expected the boundary to be very different, and interstellar space also surprised them with a higher particle density than anticipated and undefinable plasma streams. Who knows? Explorer may first even find evidence of previously unknown objects or even exotic forms of matter. Such discoveries could have a revolutionary impact on our understanding of the universe. One particularly intriguing possibility is, of course, the discovery of signs of extraterrestrial technology or signals. What is certain is that Explorer 1 will continue to fly for many thousands or millions of years after the end of radio contact. If the test encounters other intelligent civilizations eventually, it and its twin test, Explorer 2, have well-preserved records ready for a greeting from humankind. When and whether these messages will end up in the hands of other living beings is truly written in the stars. It will take Explorer 1 an entire 40,000 years to approach the closest star on its course. In any case, for many years, Explorer 1 has been a hall of distinction. Can you imagine how long the data and achievements of the Explorer mission have been with us? When this test was launched, many of you were probably not even born yet. Generations of scientists have worked with the captivating discoveries of Explorer 1 and 2 to pay tribute to this extraordinary mission. Let's review its most prominent accomplishments. In 1977, the Explorer 1 test was launched from Cape Canaveral Spaceport in Florida. After a few flybys and crossing the asteroid belt, the test reached the gas giant Jupiter in 1979. Explorer 1 explored the upper layers of Jupiter and took detailed pictures of the marbled surface and the Great Red Spot. Next, the test flew by Saturn. The flyby revealed the intricate structure of Saturn's rings and Titan's atmosphere. Explorer 1 then began its journey to the edge of the solar system, while Explorer 2, after its initial mission to Jupiter and Saturn, visited the outer planets Uranus and Neptune. One of the most famous images in the history of space exploration was taken from a distance of 6 billion kilometers. Explorer 1 captured Earth as a tiny blue dot. Then there was nearly 20 years of silence from Explorer 1. Most of the instruments were turned off to save power, and the test traveled through the Kuiper Belt and further to the edge of the solar system. Towards the end of the heliosphere, NASA switched the equipment back on, and Explorer 1 resumed sending data. The scientists needed to understand what the magical boundary between the realm of our sun and interstellar space looked like. In 2012, the time had finally come, and Explorer 1 reported an incredibly jerky transition. This demonstrated that our sun creates a sort of solid particle boundary at the edge of its influence, which acts like a thick protective skin. We have now been receiving data from interstellar space for several years. The instruments are still in operation, with its plasma wave instrument measuring the density and temperature of charged particles, which are more abundant in the interstellar medium than within the solar system but carry completely different charges and probably also have different physical properties. The cosmic ray instrument detects high-energy cosmic rays to analyze their composition and origin. Cosmic rays could, for example, provide clues to objects or structures that we might not have been able to detect before, as they lie in complete darkness. The magnetometer, which measures the strength and direction of the interstellar magnetic field, can also provide us with such insights. The test also detects low-energy particles with the particle detector. This is significant to determine whether interactions between the solar wind and the interstellar medium can still be observed. Farther in space, Explorer 1's venture into interstellar space marks a significant achievement in human exploration, pushing the limits of what we can learn about our universe. As the first spacecraft to venture beyond the heliopause, it has opened new vistas for scientific discovery and enhanced our understanding of the vast region that lies beyond our solar system. The spacecraft's trajectory and longevity are testaments to human ingenuity and perseverance. Launched in 1977, Explorer 1 embarked on a mission initially planned to explore Jupiter and Saturn. Its encounters with these gas giants provided remarkable insights into their atmospheres, magnetic fields, and moons. The famous images of Jupiter's Great Red Spot and Saturn's intricate ring system captured imaginations worldwide, sparking renewed interest in planetary exploration. After completing its primary mission, Explorer 1 continued its odyssey toward the outer reaches of the solar system. It traversed the Kuiper Belt, a region teeming with icy remnants of the early solar system, before crossing the heliopause, the boundary where the solar wind gives way to interstellar space. This historic crossing, confirmed in 2012, marked a milestone in space exploration, showcasing the resilience of Explorer 1's instruments and the dedication of the teams that have supported its mission over the years. Now positioned as humanity's most distant messenger, Explorer 1 faces a new frontier filled with mysteries awaiting discovery. Its four primary scientific instruments, plasma wave, cosmic ray, magnetometer, and particle detector, are poised to reveal extraordinary insights about the interstellar medium. These instruments measure the density, temperature, and composition of charged particles and cosmic rays, providing crucial data that will enhance our understanding of the vast environment beyond our solar system. One of the key objectives of Explorer 1's extended mission is to study the interstellar magnetic field. This magnetic field, distinct from the heliospheric magnetic field produced by the Sun, plays a critical role in shaping the properties of the interstellar medium. By mapping its strength and direction, Explorer 1 offers insights into the fundamental dynamics of interstellar space, revealing how magnetic fields influence the formation and evolution of cosmic structures. Another focus of Explorer 1's mission is to explore plasma waves in interstellar space. These waves, generated by interactions between charged particles, provide signals about the density and movement of the interstellar medium. Explorer 1's plasma wave instrument records these subtle variations, offering scientists a window into the dynamic processes occurring billions of kilometers from Earth. This data not only improves our understanding of interstellar physics, but also contributes to broader astrophysical theories about plasma behavior in cosmic conditions. Cosmic rays, high-energy particles originating from distant astrophysical sources, represent another area of study for Explorer 1. These energetic particles traverse vast distances through space, carrying information about their origins and the cosmic processes that accelerate them to near-light speeds. By analyzing their composition and energy spectra, Explorer 1 provides valuable insights into the cosmic particle accelerators scattered throughout our universe. Additionally, Explorer 1's particle detector plays a crucial role in characterizing the low-energy particle environment in interstellar space. These particles, remnants of interactions between the solar wind and the interstellar medium, offer clues about the conditions prevailing beyond the heliosphere. By monitoring their flux and energy distribution, Explorer 1 contributes to our understanding of how the solar system interacts with its cosmic surroundings over astronomical timescales. Beyond its scientific goals, Explorer 1 embodies a significant human endeavor, a testament to our curiosity and exploratory spirit. Its journey into interstellar space represents our collective quest for knowledge and our innate desire to explore the unknown. The spacecraft's longevity, enabled by meticulous mission planning and robust engineering, highlights the enduring legacy of exploration and discovery for future generations. Looking ahead, Explorer 1 continues to pave the way for future space missions and scientific endeavors. Its success has inspired new generations of scientists and engineers to push the boundaries of space exploration, envisioning ambitious missions to distant planets, exoplanetary systems, and beyond. The lessons learned from Explorer 1's mission, from technological advancements to scientific breakthroughs, serve as guiding beacons for humanity's quest to understand our place in the universe. As Explorer 1 continues its solitary journey through the vastness of interstellar space, it remains a symbol of human achievement and a testament to the power of exploration. Its discoveries will continue to shape our understanding of the universe, offering glimpses into the cosmic wonders that lie beyond our planetary system's confines. With each transmission received from Explorer 1, we gain new insights into the mysteries of interstellar space, expanding our knowledge and fueling our imagination for generosity.